two Snell's window calculations from the textbook. First one is the worked example. So the Snell's window that we're looking at is if you're a diver or a fish or you're underneath the water and you look up, you see a ring or a circle, sorry, not a ring, a circle of light. That's Snell's window. So we have a source of light P 2 meters below the surface of a pond. Find the radius of the circle at the surface if the refractive index is 4/3. So we'll start with a diagram, right? So the diagram there is on the right hand side, and we're interested in the second or the middle ray. The middle ray, the light comes up, goes from a more dense substance to a less dense substance, and then refracts along the surface of the water. When that happens, we have an angle C, which is the critical angle. Now, there's a triangle there as well. The triangle is made from the vertical black line with 2 meters on it, the radius, the horizontal line, and the middle red ray. There's a triangle there. And if we look at that triangle, the C value that I identified previously, the critical angle, has an alternate angle at the bottom of that triangle. So we're going to use some trigonometry. We're going to need to get the C value, the critical angle. That can be calculated from the refractive index. That there is in the left-hand side. Refractive index is 4/3. Refractive index is 1 over sine C. So sine C is 1 over n. And the critical angle works out at about 49 degrees. So once we have that, then we use that on the right angle triangle. We're looking for the opposite, which is the radius, and we have the adjacent, which is 2. So it's going to be tan of 48.59 is r over 2. Rearrange it, and you get r is equal to roughly 2.3 meters. If you're looking for the area here, you would square that radius and multiply it by pi, because the area of a circle is pi r squared. Example 2. So this is question 7. In this case, the light source is 4 meters below. The refractive index is 4 over 3, and we're looking for the radius again. So the blue section below, that's the water. We have a ray of light, shines up and travels along the surface of the water. If I put in the normal, that angle there is the critical angle. Now what we need to do is draw a right angle triangle with the ray underneath the line. So that'll pop up there in a moment. There we go. And A and A are the same. They're both critical angles because they're alternate angles. Now the next thing we need to do is use the refractive index to get the critical angle. We're interested in the opposite. We have the depth, which is the adjacent, so we use tan to get the radius in that case.